Good afternoon, guys. This is our research project presentation for an innovation day. And our research topic is development of a smartphone app for a smart freight traffic signal priority on urban freight corridor. This is an interdisciplinary research project. Me, Swastik Khadka from Civil Engineering Department.
Hi everyone, I'm Nishma Luitel and I'm from CSC department.
So yeah, we both are working together from Civil and Computer Science Department and we are guided by our faculty PI, Dr. Professor Tyler Lee. And in this research project, we are supposed to develop a smartphone app which will help us to guide our flight in such a way that the traffic signal priorities is given in importance or accordance to a flight to make our flow smooth. So yeah, this is our presentation and then some of the background information. So freight is like a backbone. Traffic is like a backbone of our country, and most of our good transportation import exports are done based on freight. And all those loaded trucks that are traveling, they must pass through a corridor that are controlled by traffic light. And as we all know that once a truck or a freight traffic reach through a traffic light, there is a delay because traffic light has a stop, red lights, and because of that they have to stop, so there is a delay. And the trucks delays are very expensive, reportedly like $1.50 per minute is an expected truck delay. So also not just the delay, but there is a lot of emission if the truck isn't halt. So in order to optimize our delay or in order to properly flow the traffic, there should be some priorities given to the freight. But we have to be very sure that the freight priorities is given in such a way that it is not disturbing the background traffic, and the freight priority will not interrupt with the background traffic generating heavy delays and emissions. So for this project, we are working with UTA automated traffic signal performance metric system, which is a very live arterial traffic performance, and it is also known as UTA-ATSPM system. So yeah, the software interface for this, I will hand it over to Nisma to carry on about software interface.
I developed this app using Flutter SDK and Dart language. This is our GUI. This is our front end where if you see at the top of it, you can see there's agent ID, trip ID. Those are the information that is displayed to the user through the Google Maps API we have displayed at the bottom. The longitude and latitude information are all extracted from where the car and where our location is. The speed of the vehicle, heading, acceleration, everything works according to our location and the speed of the vehicle. The second part, we are using a live camera of the phone itself to record the surrounding. So a user can either choose not to record the video or choose to record the video. um, and as I said, you can do front and back, but usually we are using it for the back purposes. There are three buttons at the bottom. Log is used to record the video first of all if the user wishes to. um, get the SRT file of by second, and then SRT, and then the CSV file of all the information of second by second. The track system here, it's track and on duty is off because we are using the free version. If we sign up and then sign in from the user itself, like when a user wishes to sign up, then the track and on duty feature is also available. The track feature is used to send the information to the to our database, and on duty uses to notify us that the any person who is using this app is on duty. As you can see on the second user, if you press that three bar button on the left hand side, you can see you can use the tracking and observer, where you can input the IP and port of the server itself and save as a file. You can choose the files that you have logged in the first UI. It is actually saved in our own phone, so you can choose the files that you could upload and share with other devices or other apps such as Google Drive, OneDrive, and you can log out after you are done. Next slide, please. So like I said, our functionalities of the app is it is safe, it is free from fake users, as when user are trying to sign up, we verify from their email, and then if they are using the free version, then there are some limitation. And we used Google Maps API to display the map and extract the information. The buttons, such as, are used to save MP4 and SRT and CSV file. The track button is used to connect to the server via HTTP post method. And the on button is used to inform user whether the vehicle is ready to send the information or not. And like I was saying, the HTTP or FTP request can be done by inputting or changing the IP and port number from the screen, which people are able to read and save it to the text file. Next slide, please.
Okay, so for the experimental setup and testing, what we did is we drive through the corridor that starts from Park Road, Road Lane, and then end at Arkansas Lane. So we did almost like 10 trips. We started from Park Lane and we went to Arkansas until we hit Arkansas. We stop our trip, and then we take a U-turn and come back to Park Road, and that was our second trip. So here is a live demonstration of how the things work. As you can see in the GPS, it is traveling around the intersection, and even on the video, we are exactly at the same location. So these also helps us to know about the efficiency and the accuracy of our software that has been developed. And it is for 15 seconds, I guess. Yeah, and then after experimental result. So what are the information that we can extract from this software? So definitely we can extract agent ID, which in our case, since we are the owner, it's one, and we have a trip ID. It depends on how many time you have turned on and turned off the trip button. So every time you turned off, it goes to a next number and it becomes a next trip ID. So this is the example that I've shown is for second trip ID, and it goes from second by second. And also we have epoch time and time. So first I think we generate epoch time, and through our internal system and programming, it convert it to a regular time. And then also it extract latitude, longitude, and then speed, and the heading, which means the angle in direction angle. So with all this so with all this information, how we will give a priority or a flight priority at the signal. So what happens is these are the information are sent it to a system. In our case, it is UTA-ATSPM system, which is interconnected to a live traffic. And so what it will do is it will look around like where the freight traffic is, and what is the amount, like how heavy the traffic of freight is, and it will try to give at least a green time to that freight which is approaching towards the intersection. But we have to be very careful, because if we give more priority to the freight traffic, then we might end up getting long delays for other opposing traffic or opposing direction, right? So yeah, the optimization portion, the green time portion, and all of the traffic characteristic portion is a different research topic that is very different from this. But with the help of this software, we can really interconnected both of this research area, and help our freight traffic to flow in a proper direction, or in a smooth way with a high optimization. So yeah, so with this app, we expect that our flight signal priority would not be as difficult as it is now. And yeah, it was based on Flutter framework, as Nishma said, and with the help of obtained result from this app, we can allow more flight signal priority without increasing the delay and emission of the background traffic. Thank you.
Thank you so much.